Thank you very much, James. And thank you, Margaret, for the invitation, and especially for such a meeting with such a fantastic title, such as the word inspire, because certainly I think working toward inspiration is a very, very important goal, and one that is extremely linked to the whole concept of sustainability, because we are trying very, very much to change from business as usual to something that will help us all move forward in a more positive way into the future. I've slightly retitled the talk here to match a little bit more to what I will be addressing in a more concrete manner, which is how can the things that we know how to do as professionals help industry to meet their UN Sustainable Development Goals. So this is a very concrete type of subject, and one that I'm actually quite passionate about. Just to say something about myself, I am retired. I have been an associate professor of systems engineering, and the letters after my name stand for Expert Systems Engineering Professional. So I am actually someone who has 30 plus years as a practitioner and then 20 plus years as an educator. So it was a very, very rich career, for which I'm most grateful. And I wrote my PhD thesis on the topic of the application of systems engineering to eco-industrial park development. So I came quite honestly into my interest in this topic area. One of the things that I always try to do with any talk that talks about sustainability is to create a context for what I mean, at least during the time that I'll be talking with you, and most of the time when I talk with others as well, is how I define the concepts of sustainable development. And I think any of you who have read in the topic area know that as many people as are writing or thinking about the topic, that's pretty much how many definitions you may find out there. So it's very important to set some groundwork. What you see in this picture is sort of what I see as the as is and the to be picture, which is something that as systems engineers, we try very, very hard to establish our groundwork in what do we know about today's situation as it relates to where we want to evolve, where we want to be when we're finished working and finished achieving our goals. So on the left-hand side, you see that we have the process of creating a product, which tends to be a simplified way of talking about what happens in industry. And we see that typically the systems engineering focus has been pretty much on getting to the design and creation of the product, and not even so much with the sale or other types of after useful life issues, even though you can find readings on the topic. And what you see also is that Mother Earth is sitting there as the supplier of raw material in almost like a cornucopia type of situation, and then also the receiver of all types of waste that comes out of the process itself past the intellectual portions. And where I'm taking the thoughts today is to expand where we as systems engineers are accepting responsibility as systems thinkers, or pretty much anyone who's on this call probably can relate to having some responsibility in this life cycle. And what we see right away is the focus is expanded to the whole life cycle. The reliance on Mother Earth tries to be presented as only being possibly a source of the raw materials. And she's smaller because we don't want to think of her as a cornucopia that is without end and could be, harvested forever. And then what we see also is that as we move through our process of the life cycle of any given product, that we have waste that happens as it did on the left-hand side in each of the phases. But there are ways to make the waste come back into the entire life cycle and into the entire process, such that we can more realistically reduce our dependency for raw materials on Mother Earth. And this also could be a diagram that sort of represents the types of theories and discussions that happen in literature and theoretical work on the circular economy, where we are trying very, very hard to create this spiral reclamation of waste such that it doesn't go into landfills and it does go back into the life cycle. And this, for me, is the picture of the before and the after of unsustainable versus sustainable development. I did this work under the auspices of my PhD research and created a case study where I was looking at members of an industrial park. And when I was finished with my readings and my literature review, I realized that the three pillars of the whole ecological and sustainability thing, which are social equity, good economic performance, and good attention to the natural environments. And so what we see is we can put this into a matrix and look at what it means to work towards sustainable development. And you see at the very, very left lower hand corner of that quadrant, the most important thing is to start out becoming aware. And so this is another reason why I love being invited to do this talk, because I feel that for anyone not already into the awareness phase, this is a good way to start to understand. And then we start to look at, as we improve our appreciation and our activities toward creating good social equity, toward being more attentive to the natural environments, that we are applying different techniques. Eventually, these techniques are integrated into the way our company acts. And at the very highest right-hand level, we do have companies out there already that are excellent role models for and providing leadership into what it means to be this type of firm. However, being aware all by itself isn't sufficient, and it's extremely challenging for companies to know what they need to do. So we have what I'll be reporting on today is efforts that came out of a research project called the Capacity Building and Sustainability and Environmental Management, which was a CAPSIM project. And it was funded by both the Erasmus and the program of the European Union. It concluded its work in 2019, and you can see quite a lot of different logos there. Many of those are academic logos. There's one or two industry partners in there supporting research where it was done. This was very, very important, and what you'll see is that some of these logos, which we don't necessarily always recognize, all of them come from Uganda, Nepal, and India, who provided industry partners for this particular project. The whole intention was then to create a structure of the methods and concepts related to sustainable development and structure them in such a way that they're manageable and can be taught and learned in a logical way for practical application. And then also, as we're trying very much to increase the number of people who understand this, also for knowledge transfer. So all of this is wrapped up into this CAPSIM project. You'll see some references for folks who want to read further. So that what they came up with then coming out of the project was what they call the CAPSIM model, which was intended then to assist organizations as they feel this pressure to improve their performance, but maybe don't know what they should do first, maybe realize that even if they knew what to do first, they may or may not have the correct resources on hand to take the first steps. And this model has been derived in 4 levels: to look at the production processes, to look at products and their value chains, to look at an organizational level, and then to look at a meta-systems level, which would include entire sectors or societies. And again, there's an open source book, which is mentioned here as well. So the CAPSIM model looks like this. And so clearly, and with some apologies, it looks like a lot of alphabet soup going up on a wave of transitions to reach a more sustainable level. What needs to be said here is that level 4 isn't a last level. Level 4 is a trickle down level that, in fact, all of those particular techniques, which are systems engineering, material flow analysis, and industrial ecology, are actually applied from day one. The theories embedded in the level 4 systems change are critical to understanding how to affect those changes. The various processes then that are offered at each of the other levels are somewhat more specifically oriented to the work that would be done. So at the beginning, you might map out your industrial setting to understand what does your company take in, what does your company produce, and specifically also, do you understand the wastes that are produced by your company? And then you have the CP, or the cleaner production, which would be the set of theories and practices that would help you to address those. Then we move up into level 2, which also actually affects product design. And many of you have probably heard of life cycle analysis or supply chain management, the carbon footprint. So the things designed for the environment. So the sort of things that we look at as we design a product, build its product value chain, and then try to continuously improve at that level. At some point in time, and again, maybe even earlier than where it appears in a seeming timeline, but it's really more of a scope, are the organizational changes that need to underpin making successful progress toward reaching your company goals towards sustainability. This is a very loose mapping then of the various levels and which of the UN sustainability goals might be addressed most likely at any given level. And what you sort of see in that lower right-hand corner are the more generic goals that are, again, influential across the entire process. So one of the things, and to just say, Margaret, no, continuous improvement is built into the fact that it's a wave. So that is the point. It's a transition. It's continuous. Just because you've done some cleaner production analysis down at level 1, as you're moving through and becoming organizationally more mature, the techniques of cleaner production or the techniques of LCA that you might apply would improve, might expand, and become part of your total cycle. So you can start quite simply on any of these different recommended methods and theoretical areas, and be constantly applying new and better techniques towards improving. So the idea is that sustainability is sort of a little bit like any life goal. You're never really quite done. You're constantly looking for, have you addressed everything that needs to be addressed? But thanks for that observation. One of the things that is important to also appreciate is that the concepts that are embedded in sustainability and some of these techniques are not brand new or not known already to the industrial environments or the academic environments. Things like cleaner production, LCA, the design for environment, etc. These have been known for a while. And Professor Fett, who was very instrumental both in creating the CAPSEM project, but also in a lot of the literature and the authorship that has gone behind making this information available to the universe, as it were. And she has also tried to structure this against a systems engineering perspective, where you see that is in the left-hand corner, where you start by knowing what are the needs, what are the requirements, how well should things perform, what sort of options do I have, what sort of analysis do I need to do to get better at this, then getting into design, and of course, obviously, verifying and then continuously improving in step 6. And so each of these other methodological silos also have ISO standards written against them, and those ISO standards, for the most part, say follow a process that maps extremely closely to the first column, and the actual language from the ISO standards itself, which is like commitment and planning and strategies and implementation, they are shown in each of the different columns as we go along. So I'm not here to do a talk on all of the different possible techniques that you can apply, but they're all well documented in literature. So what does some of this look like to be just a wee bit more concrete? So if I do a material flow analysis of my production processes, I see that a company has to take in energy, probably water and other raw materials to put out a finished product. And more likely than not, there are going to be emissions to air, hazardous waste, waste that's suitable for recycling, discharges to water, perhaps, and discharges to soil. And so all of these types of understandings must be evaluated and discovered and documented. So it's not just to know, yes, I have some waste that's going to landfill, but how much, what tonnage does my industry or my company contribute to landfill waste, as an example. And the type of strategies, and this is just an extremely simplistic view of the cleaner production view, is that I could either be looking at recycling, so taking things on or off site, or I could actually be looking at what is it in my process that's creating this waste, and what could I do to either change my production techniques or processes, or possibly even minimize certain types of source materials such that I'm not creating hazardous waste, or I'm not creating waste that has to go to landfill. And so you see that these are techniques that are very, very embedded in cleaner production strategies, where the source reduction would be clearly preferable, as it has a more longitudinal positive effect than just relying on the recycling or reclamations. The life cycle assessment, as I said, that's very, very much talked about. The literature you see more and more every day, and that has a very, very formalized process, again, starting with what is it that you're creating or you're evaluating, creating it and describing it in something called a functional unit. The functional unit very often is reduced to a measure of how much carbon dioxide or other greenhouse gases are emitted as a result of doing this process, and then discovering impacts and performing the various phases that are important to LCA. So again, there's lots and lots of literature out there. And what happens is that you can have a product that during its useful life, such as an electric car, gives an impression of being something that's very positive toward sustainability on the planet. However, if you go back and you look at what raw materials are required to go into the production of an electric car, the very large and impending issue that will hit the planet shortly of what do we do with batteries when they are no longer appropriately in use. These are things that would be considered as part of a life cycle assessment and might in fact give us a different impression of electrical vehicles. And not that I'm necessarily down about them, but at the same time, they may be getting better hype than they deserve. Design for environment. Here we have a very large design type of view, and what we see is that the part that's in the dotted line are very, very much part of the whole systems engineering perspective, where many of the other things are also done by systems engineers, but might might have a lot of other different techniques and skill sets that come to play in order to do an effective design. What you do see also is that none of these particular methods actually work or should work completely alone. They should be working in tandem. So you see here that the idea with this diagram is to show how both LCA, design for environment, and supply chain management techniques might be involved and work together to create a truly sustainable product. This is another set of ISO standards, and these tend to be the ones that, as you're doing your work and you're documenting what you do and you're documenting your findings, and you're sending this information out either to regulatory committees, or you're providing this information to your customer, the little box in the lower left-hand corner, or the environmental labeling or product declarations that are becoming more popular now, both in food stuff, but also in furniture, etc. So you're starting to see that there are management level techniques, and that if top management doesn't support what's being done, clearly the impetus to continue and to continuously improve, as was mentioned by Margaret, certainly might die on the vine. Also, this slide I've kept to show that we're really talking in very, very explicit terms. Now, there's no real numbers here because the actual number would depend on the company or the situation that was being measured. But you see quickly that these are quantifications, and what is necessary is to understand how is my operation performing, how is my management team performing, and keeping, again, a continuous tracking of how well things are being executed in a day-to-day manner. Here, some of this is blown up, so you can see, what's my energy usage per year or per unit of product, if I can get my analysis down that fine, and how am I measuring that to my financial performance. So you see that these are measurements that are very explicit and very, very important if your company is going to truly achieve an issue of sustainable development. I mentioned industrial ecology as being one of the overview bits, and this is a course of study and analysis that's been around for some decades now. You'll find the term goes quite far back, and it's very much tied into the very first diagram that I showed, which is, moving from seeing the planet as a source of unlimited resources and somehow being able to absorb unlimited waste, to gradually introducing the concept of more limitations and more cyclic performance within our human processes. So you eventually see that strong cooperations between material extractors, between producers, and even with our consumer are necessary to really reach an industrial ecosystem that is sustainable. So these are just some very, very high-level simplified view of what we're attempting to achieve by looking at production as an ecosystem. Lots has been written, and you see already this goes back to 1994, and it's not probably the oldest of the references that you could find, but what you see is that, again, there's a sense of constantly improving. There's a sense of closing loops, and again, we see today's literature talking more and more about circular economies. This is the loop closing that we're after. Dematerialization, in other words, can a product be made with less dangerous material, or can it be made with less material completely? Can it be created by using less energy? Does all of our production have to be so energy intensive, especially as we talk about cost of energy now becoming a critical operational component? Seeing energy actually built into the way we think about the ecosystem for production, which hasn't always been the case, and then balancing all of the different factors of our ecosystem, but at the same time also aligning policy such that it motivates and contributes to production and industry making good decisions. We talk often, I think in academia, but also in other environments, about how the law very often lags behind what's necessary to actually achieve good benefits in society. And this is also something that needs to be addressed if you're thinking of the large ecosystem and industrial ecology. So here's a set of references similar to the way the first keynote speaker gave you. So you'll have these when you receive the slides. There's a couple case studies then that were done under CAPSEM. One of them looked at applying the whole CAPSEM concept to the construction sector. And so we have some papers on that. And again, how the different levels contributed and how they increase the scope of compliance to sustainability in that sector. And again, a sector that by its own admission has a wee bit of a ways to go to be classified as sustainable. However, we do have some little bright lights, and one of them is this green, BREEAM, you see in the corner there. And if I was privileged to have a student who had worked with green certification as she was working towards her systems engineering degree. And one of the things, again, that she was able to do was find a very clear mapping between what the steps that are necessary to achieve a green certification and the steps that systems engineers practice on a daily basis, as represented by a loosely constructed V diagram. And so this again is an article, if you're even remotely interested in the construction industry, that could be interesting for you to follow up. As I've also said, this is material that's been being developed really over decades. And one of the nice success stories that Professor Fett has had is that even starting with her own PhD research and work that started also back in 1993, working with a Norwegian shipyard and working toward their continuous improvement, starting with waste minimization, and then how do they clean their hulls in the shipyard and implement other cleaner production types of techniques. How do they address the whole life cycle and apply greener technologies? And then eventually, what sort of reporting and certifications are they eligible to achieve because of all of the hard work that they've been doing over decades of actually, making a cleaner shipyard. So this is longitudinal work, and quite frankly, this shipyard is still working every day at doing things a little bit better than they did them the day before. So one of the things that happens when you talk about this topic is you get invited to listen to other people who are concerned about this. And I recently heard earlier this year a really excellent communication just talk from a speaker who's been also doing this for decades. And one of the quotes I took away from his talk was this concept that transparency is a management tool. So when we talk about, at level 3, the organization is there. Well, in fact, organizational commitment also needs to happen before anything else happens, before we get off the beam on level 1. And so what we see is that in his mind, the primary stakeholder for the change toward a more sustainable industrial setting is actually the chief officer, the chief executive officer, or whatever he's called where you work. and their commitment that change is necessary and change needs to take place. And essentially, by listening both to what's being said in the outside world, but also working within the company itself to identify and coordinate different actions that take you along that transition pathway. Working also externally with the supply chain and other partners, because you may be doing internally this wonderful job, but if whoever supplies your raw material or whoever accepts your finished product is sort of not working in a responsible way, your whole product chain is really not fully sustainable. So the idea is to work within the partner constructs and also to build other types of stakeholder support and participation. And what he also alluded to in his talk in April was that shareholders, the people who are invested in a firm, especially if it's publicly traded, they are also important to bring into the vision and to say, yes, I want to invest in a company that is like this. When we touch briefly then on this idea of education and what are we looking to build in terms of the type of students that we graduate, what should they be able to do? And clearly, due to the scope of what we've been talking about today, they're going to be fairly generalist. They may have a small specialization, but they've got to be able to do quite a lot of different things. And ironically, our past language of talking about the soft skills, for example, anything that's not engineering or math-based, as though they were the simple skills. In fact, we're starting to wake up in the educational community and realize that they may actually be the hardest things to teach, to learn, and to apply. And so team building skills, collaboration, being an active learner who gets a lifelong thirst for living, improving our own ability to communicate, improving our ability to see big pictures and apply other elements of systems perspectives, looking at integration and understanding that we're going to have to work with people with lots of different types of backgrounds, and even starting as early as curriculum development. Understanding the diversity of people from different cultures, having different business practices, working in different domains, also very, very important to build the proper kind of sustainability generalists that we're going to need in society. Looking at social, economic, environmental impacts of engineering decisions and being able to understand their implications. Our commitment to quality and timeliness and continuous improvement. And then undergraduate research and engineering work practices experience as being a way to learn by doing and not to leave out ethics. I saw that ethics was one of the topics that was presented also to this morning's keynote speaker. One of the things I also discovered was this wonderful little shell and diamond of sustainability, which I found it once and I've never been able to find it again, but I know who made it. Bo Schellen of Sweden. And what you see here is all of these different things that I've just sort of itemized a wee bit also in the previous slide to show that no one of these things is fully sufficient by itself. They have to be working together, policies and politics, working with health and the needs of the population and the environment. So everything is somehow connected, and we need to recognize it and make it work that way. And again, the bottom line in this case is human survival. So with that in mind, there's a little quote that I found also while I was doing my thesis work, which I kept posted on my desk because it's sort of on the outside chance, which didn't happen, but on the outside chance that I would have lost any of my motivation, it was something that kept me on target. And then with that, I'll say thank you very much for your attention, and I'm also open for questions.
Thank you very, very much, Cecilia. Really wonderful. It's time for questions now, please. Anybody have any question?
Oh, James, could you put your volume up a bit?
Oh, okay, to put it up.
Thank you.
Oh, okay, yeah. Can you hear me clearly now?
Better, thank you.
That's good, yeah. So thank you very much, Cecilia. I think that was really quite enlightening. Now it's time for questions, please.
So I'll start with the second question from Margaret. Margaret, I'm assuming that I addressed continuous improvement sufficiently through the talk?
Mm-hmm.
Okay.
Yeah, definitely.
Okay.
I'm leaping up and down and clapping the whole way through.
Oh, you're so sweet. Thank you. And so also, I think at that organizational level, you might have also observed that auditing and auditing both internally because you care how you're doing and whether you are improving continuously, as well as auditing that may in fact come from external political environments or regulatory sources. So that it definitely happens. Yes, and it's definitely built in. And again, it goes back to this situation that I mentioned of the legalities very often trailing the needs of the both the planet, but also of industry themselves. And so perhaps whether there might not be the potential for improved law such that also we might audit on more topics, but that's, you know, that's for a different talk, I think.
Yeah.
It's a lot to take in, so I'm really sympathetic, but maybe let me start by seeding with a question. I'm wondering maybe yes, auditing usually is a legal requirement, by the way. So I'm wondering how many people I don't think I can do show of hand. Let me see if I can get the whole view.
Could I just follow up on that legal requirement, because a company has to put in the accounts as a legal requirement, but do you think sort of almost globally the sustainability auditing results ought to also become a legal requirement in
and
the
in
future?
Europe there are more legal requirements along that way, but again, it's one of those things where you can do a 2-page report, you can do a 400-page report and still meet your requirements. So do keep in mind that legalities really rarely get us to a point where we're satisfied. Yeah. I would like, by show of hands, use your React. How many people have not heard of any of, and I have my gallery open, so I'll see. How many people have heard of none of the alphabet soup that I presented in CapSim today? Ooh, good. No hands. I'm hoping that you're all still actually there.
Yes.
How many people have at least heard of LCA, the life cycle assessment?
Yeah.
Yeah, use the React. I can't see hands if you aren't reacting.
Yes, I've used the React. Yeah.
Yeah.
So Margaret and James.
Yes.
And Xing Song, thank you. So the rest of, and Linda, thank you, Linda. So the rest of you are sitting here listening and you've actually not heard. Well, then I'm going to suggest as a result of this, okay, and James, yeah, James, you said that maybe be one of the places that's easiest for you to start. There's so much material out there. Thanks, Angela. There's a lot of material out there about life cycle assessment, and there's even specifically a lot of material about life cycle assessment as it relates to electric cars. So, you know,
that it leads me to sort of, or triggers me to ask a question.
Yes, go ahead.
Systems engineering, for me, being introduced to engineering practice and engineering education, I've come to realize that systems engineering is very, very important. And then I did take a course. I did develop a module, control engineering. And
Okay.
So why is systems engineering and system engineering practices not sort of introduced in our higher education institution as something that is maybe quasi-compulsory, because systems approach to finding solutions to society problems or machine problems is the best way to find the solutions to these problems.
Yeah, I mean, certainly, I suspect that your thoughts might also mirror many of the other people on the call today. And certainly as a practitioner, as you saw from my brief summary of my own experience, there are industries where it grew up, and one of, such as the military complexes and airplanes, and even the automotive industry has used these techniques. But one of the things that's challenging is that systems engineering very often is presented as a drag on the process. There are many of the pieces of literature and books, et cetera, that make it sound like something that's so complicated that all you want to do is run in the other direction. And yeah, okay, there might be benefits from it, but it's like anything else that's beneficial. I don't have time for it. We certainly see the whole head in the sand kind of technique that many people use. I'm going to share my screen, and all righty, good girl. And here we go. And I'm going to answer your question by showing you what I did during my PhD work, which was I identified what are the essential components of systems engineering. But if you do this, you're doing systems engineering, even if you don't do. When I did the research, I found literature that supported the idea that there would be a superset of engineering processes, systems engineering processes, that included 38 steps. So I think if I went into an organization and said, here's 38 steps, and you really need to do these to be effective, they'd all pretty much politely show me the door. But if I come in and I say, here's something straightforward, like, and while it's circular on purpose, because you might come in at any point in your own process instead of at the beginning. But if you came in at the beginning, the advice would be understand who cares besides yourself about what it is that you are interested in, or the challenge that you're seeing, or the observations that you're making. Who else cares? And that's the S, and it stands for stakeholders. And then the P stands for problem formulation, and it says, okay, here's all my stakeholders. Can I sort through the diversity of opinions and observations that all these stakeholders have and identify where the challenges are, formulate some very, very specific need that should be addressed. The A is analysis and alternatives, such that I don't just jump to a point solution. The D might be doing a pilot program, making some decisions about how might I approach making things better. The E is in the center, and it stands for the word evaluate, because at every stage, whether you're looking at stakeholders, it's like, oh, is there another stakeholder out there I haven't found yet? When looking at the problem formulation, is there a formulation of this problem that could be improved or be made more relevant to the stakeholders that are involved? Are there alternatives that I haven't considered? Is there a course of action, the D, is there a course of action that I haven't considered taking that might actually be better than what I'm doing today? And so the E is constantly applied to the entire process, as well as an evaluation throughout the process also. Am I doing the right things? Am I doing them well? Am I being effective in what I'm doing? And so this, to me, this is what I teach as systems engineering. This is what we've been teaching in my university, and it's helpful.
Okay, thank you very much, Cecilia.
Yeah. Could I follow through on that, your diagram there? When I think about your research, I assume that you were talking to lots of companies. Did you find a difference in view between the SMEs and the big companies?
Actually, in my research for my PhD, I only was working with SMEs. And that was part of the reason I had to streamline it a bit, because the larger ones, they've heard of the big complicated system engineering. But because they've heard of the big complicated systems engineering, when you walk in with a streamlined process, they actually get a wee bit excited about it. So, so the answer is that I made it because of the SMEs, but I found the big ones really liked it too.
Oh, thank you.
Mhm.
Okay.
I'm not sure if I'm over my time. I'm trying to behave here.
No, I think we're still in time there, but 1:15 is the next one.
Okay.
Yeah.
Oh,
I think that's
okay.
brilliant.
Yes, we have some few more minutes in case anybody have any more
Okay.
questions.
If anyone else would like to ask me something.
I hate to ask you another one because I've asked too many questions.
No, please do, Margaret. Yeah.
I was thinking about, you were saying about this is something that maybe we ought to try and push through the BCS. And is it something also, in Norway, is it being pushed into companies? Is it pushed into the professional bodies? Is it pushed into the schools, colleges? I know your college, your university would, but
Well,
more widely.
even in my university, they've been dragged kicking and screaming into letting me teach a course. I don't think I think everyone on this call probably has enough experience to know that the word push is the wrong word. Nothing ever gets successfully pushed. So I like to do this sort of thing. So hopefully one day somebody pulls and then says, wow, yeah, please come here and tell me about this. And we do, but by addressing students. So at my university, I can say this, that there are a lot of projects, and that I try to integrate myself as a mentor onto as many of our projects, like the project that makes a little car, the project that makes the rocket, the project that makes the tunnel. So those students get that vocabulary, and like just this February, a student who had been on the car project, but that was like 3 years ago. He called me and he said, my company needs systems engineering, please come. So it's never really, to be honest with you, it's never push. At the best, it's a reluctant pull. And then when invited, I show up. But no, it's, although I have to say this, I think the European Space Agency has put systems engineering as a requirement for projects that they fund. So there's occasionally, again, that you get someone who's enlightened and they put it into a requirement for doing business. But beyond that, it's not a lot of pushing going on. So, unfortunately, I'd love to have the magic wand. Yeah.
Please.
Okay, I think you're either lost your microphone or you're looking the wrong way.
I did say, if you
No,
find the
still can't hear you,
bullet-
Margaret. I mean, I know you're talking, but it's a murmur.
Okay. If you find the magic bullet, do pass it on.
Yes, of course. Promise.
Excellent. Thank you very much, Cecilia. Really appreciate it.
Okay, no worries. Thanks so much. And I'd probably be lingering in the background and hearing these next few excellent speakers who are coming. So thanks again for the invitation, and thanks everyone for your patience.